Hi, in this video, we are going to focus on integrated rate law. Reminder, you have to always remember the integrated rate law and also the formula of the half-life for zero, first and second order. Let's look at the question. A first order reaction is 38.5% complete. And then you have to look for the rate constant, the half-life, and also the time taken to reach 98.5% completion. First, the question is not mentioned about the reactant, so we can use any symbol to represent the reactant. So before you start, you can write this. Let A equal to reactant. Second, we try to understand the meaning of this symbol. Basically, it means concentration at that time, or in other words to say is the concentration left over or remain at the time. So let's look at the question here. 38.5% complete means 61.5% is left. 95% completion means 5% is left. 30% deplete means 70% is left. 80% decompose means 20% is left. So how you get this value? Basically, we are using 100 because initially we consider there's 100%. So and then these are the percentage that is decomposed. So that's why we minus the value given and then the answer will be considered as the remaining concentration. So there is another type of question. The rate constant is 0.083 molar per second. Initial concentration 3.5. We are going to look for the how long, the time for the concentration of air drop to 1 molar. So in this case, because of the word drop to, so we are not going to use 3.5 minus 1, but we will say that concentration at the time is 1 molar. Okay, in this slide, we are going to focus on how important to identify the concentration left over correctly. For example, 38% is complete, which show that basically is 61.5% left over, which caused the inaccurate answer for rate constant, which the answer for the rate constant will bring to the formula half-life, also cause the value of half-life is incorrect. Then for the C, to reach 95% completion, which also means the concentration left over is 5%. So in this case, the student only able to earn 2 marks. If we look at another student who identify the concentration and time given correctly, will allow the student earn 6 marks. Okay, we are look at another question. Determine the time needed for 30% of Q, a radioactive substance to deplete. So from the question now here, we will get the idea that the concentration left over is 70% because 30% is deplete. So if you look at the answer given from this question again, the student identify the concentration at time given wrongly, which caused the time identified also incorrect. At the same time, we also noticed that the student didn't put the unit for the time. So even the answer is correct, you also will not get the mark for the final answer. Next, we look at this question, the student is use the symbol A. So if you want to use the symbol A in the following calculation, you have to add on one statement, let Q equal to A. Or you can just substitute the A with the symbol of Q, then will be okay. So for this question, even though the student use the correct formula and identify the concentration and time given correctly, but then at the end we notice that the unit of the time is incorrect. Always remember that the unit of the time is always without any exponent or power. Okay, second part of the question, you are given the rate constant with the unit per year, and also from the question above it says radioactive. So with these two indicators, we know that Q is undergo first order reaction. Okay, then next we look at the next question. Sketch the appropriate graph to prove the order of reaction. So with a very general idea, we can plot the graph concentration versus time with a curved line. So if you look at this question, the students identify and label the graph y-axis and x-axis with the unit. However, the unit of the time is year. Either you use the full terms year or the short form will be YR. It is not Y. Okay, and then we also notice that the student, if able to change this title to concentration of Q versus time will be better. Okay, let's continue with the third question. This question is asked us to identify the order of reaction. So the student gives the reason due to the unit for the rate constant is per second. So the order of reaction is 1. So if you use the term 1, it is not accepted, but we need to write down the order of reaction is first order. Okay, at the same time, we also notice that students cannot explain why they know that it is first order. For example, like this, seems like the examiner have to guess is because of the value or because of the unit. Then you decide that the order of reaction is first order. Okay, continue with the second part of the question. How long it will take for 80% of a sample decompose? So 80% decompose means that at the time given, only 20% is left. So if you substitute the value here correctly, then the final answer will be correct. Okay, at the same time, the third part of the question is asked us to identify the half-life. So if you can remember the formula, half-life for first order is ln 2 over k. So k is given in the question, so you can also know the value of the half-life. But again, remember the unit is second. So basically for the interpreted rate law, I think there is a few things that you have to remember that. The first one is the formula for the integrated rate law. And then second is the formula for the half-life for all the three zero, first and second order. And the third thing is you have to identify the concentration and time given correctly. Okay, that's all for this video. Thank you for your